Hi guys, and welcome to this video on similar triangles, part of the general maths 1-2 course here in Australia, but valid throughout the world. And if I'm honest with you, one of the stupidest subjects on the planet. Yes, I am so sorry. I will get my aggression out here and now before we even start. Why? Why is this on the course? My name's Darren from mathsguru.com. Thank you very much for watching. This is the last video in this particular chapter and series of videos, and I'm thankful to Cambridge for allowing me to use their stuff. Greatly appreciated. You guys rock. Before I get into this, can you do me a favour? This is the needy bit. You hear it at the start of every video. My apologies. Can you subscribe? Click the subscribe button. It means the world to me. I am sitting here, as usual, on my own, looking out at the most amazing view and just talking to myself. Well, not really. I'm talking to you. But subscribing just tells me that someone out there is watching, and I swear to you, it means the world to me. So thank you very much if you can do that for me. I'm not going to tell you what we're doing because I've just pretty much said that. But we're going to look at similar triangles, and I just told you what we're going to do. I'm going to stop doing that. Now, in the last lesson, we've looked at similar figures, we've looked at similar solids, and basically now we're going to look at triangles. So do you think the theory changes? Well, a little bit, yes. Similarity. Basically, if two things are similar, it means they have grown by the same ratio. All of it has grown, or the side lengths have grown by the same ratio. I shouldn't say volumes or areas. So if we look at this one here, we've gone from 4 to 8. By how many times has that grown? 2. Easy? Easy. Has the 3 times by 2 to 6? Yes. Has the 5 times by 2 to yes. So in that situation, it's nice and easy. They have told me the 3 sides, and I can check the 3 sides. But what if they don't give me those side lengths? Well, generally speaking, for rectangles and cuboids and stuff, they don't need to give you all of the information. They can just give you a limited amount of information. But for triangles, it's a little bit more tricky. What I need you to understand massively is that when we grow a triangle, when a triangle grows in size, while its lengths may grow, the angles stay exactly the same size. And that's part of what we're going to move on to in just a moment. So while the sides may grow, the angles never change size. And that's actually pretty much part of what we're going to be looking at now. Now, there are 3 rules for triangle similarity. So they may give you some triangles and say, are these similar? And you're going to turn around and say, yes, they are similar because, and you're going to choose one of the 3 rules. And the first one rule is the AA rule, which again, I think is an unfortunate name because AA stands for lots of different things in different parts of the world. But let's look at the AA rule. Now, A in maths stands for angle, or particularly in this topic. So wherever you see a capital A, it stands for angle. And in a minute where you see a capital S, it stands for side. So that basically means ratios or whatever else. So this stands for angle. In here, we notice that when we are given 2 angles, the third one we can work out. So if we know 2 angles in a triangle, we can obviously work out the third one. So if this angle here and this angle here are the same, and we've got our bigger triangle and that angle there and that angle there are the same, then we know that third angle is also the same. And because all the angles are the same inside the triangle, they must be similar, right? Because the only way the angles will stay the same size is if the sides have all been grown by the same ratio. There's no other way. It's not possible to have the angles inside the same if the sides haven't all been multiplied by the same thing. So that's the AA rule, right? We look inside, they've given me some angles, they go, hey, 2 of the angles are the same, the triangles must be similar. Then we get to the SSS rule. I wonder what SSS means. Yes, sides. So the ratio of the sides. So S stands for ratio of the sides. Now what you notice here is they've not given me any angles inside this. And whilst in a later chapter we could work all the angles out, seems like a lot of hard work. Yes, absolutely. So in this situation, the SSS rule is we check that the ratios of all 3 sides are the same. So let's see. We would in this situation say, well, what is 2 divided by 1? Well, 2 divided by 1 is 2. Okay. What is 4 divided by 2? 4 divided by 2, also 2. What is 5 divided by 2.5? 5 divided by 2.5 is also 2. So because all of the ratios are the same, then the triangles must be similar because we've multiplied every single side by the same number, hence it must be similar. See what you're doing here? So we've got the AA rule, and now we've got the SSS rule. And then we've got the SAS rule, which is, I think, the military secret, like, the military, I don't really know what I'm talking about anymore. If you noticed, I've been doing this for hours. I'm talking to myself. SAS rule stands for side, angle, side. So what we're saying here, and this is more the interesting one, is that if we are given two sides and one angle, then because that angle and that angle are the same, there's the A, all right? So there's the angle, that one angle there and that one angle there are the same. It can be shown, and thankfully I don't have to show you guys, that so long as the ratio of two of those sides, or the ratio of enlargement, is two of those sides are the same, then life is good. It will be similar. So here, if I do 19.5 divided by 6.5, 19.5 divided by 6.5, I actually get 3. If I do 21 divided by 7, I get 3. And so it is shown that in that situation, these two triangles here would also be similar. Yeah, because if I've grown these the same, and that angle there stays the same, then this angle here, or that side length there, would have to have grown by the same amount. Okay, so we've got three rules. What were they? They were AA, they were SSS, and they were SAS. Okay, so let's see. Explain why the triangle ABC is similar to triangle XYZ. So let's look at that first. ABC is just a way to describe a triangle, right? And we tend to use the letters on their corners to explain them. So ABC is that triangle. XYZ is that triangle. Now, obviously, because they're different triangles, I can't use ABC here as well. Sometimes we use A dash, B dash, and C dash. But, right, which one of these rules are we going to use? Why is it similar? Well, let's check. I've got a side, and an angle. A side, and an angle. So before we go any further, I'm fairly sure that hopefully it's going to be the SAS rule. But I have to check. How do you check? Well, number one, you say angle is the same. So that's rule number one. And then what have we got to check? We've got to check the two S's, the side, the ratio of side length. So let's just check the ratios. So the ratios, how do we do that? 21 divided by 7. Well, I've got 21 divided by 7. 21 divided by 7. 7, 14, 21 is 3. So now let's just check the other sides. 24 divided by 8. 24 divided by, let's try that one again. 8 is also 3. So therefore, we can say that because the side ratios and one angle is the same, is we can say therefore SAS, right? Or they are similar because of SAS. Show that the smaller triangle is similar to the larger triangle seems very similar. Haven't I just done this? Well, it's not going to hurt, is it? How many sides have I got? 1, 2, 1, 2, and I've got an angle. So the chances are, what were they? They were AA, SSS, SAS. So we haven't got two angles given. We haven't got three sides given. So the chances are it's going to be this one. So let's prove it. Sort of, right, number one, the angle is the same. And number two, let's check the ratio of side lengths. Right, so let me see. We've got 18 divided by 6. 6, 12, 18, which is also 3. And we got 15 divided by 5, which is also 3. So therefore, we can say they are similar due to SAS. Yes! Believe it or not, I've run out of examples, which worries me just a little bit. I could have maybe done a few more, but to be honest with you, they're very, very similar. Yes, if you have three sides given, then just check the ratios are all the same. If you've got two angles given, then basically you can just write down AA, and hopefully that's one of your exam questions. I'm done. Thank you very much for watching this very short 10-minute video. I really appreciate it. Subscribe to YouTube if you can. Tell your mates, tell your teachers, TikTok, and do whatever else you can. It would be greatly appreciated. The more people I can help, the better. This is the end of this chapter. I will now record another chapter's worth of work. Hopefully I'll see you there. If not, take care, and please stay safe.